This is mathheals.com, where you can find more links to math and computer science YouTube videos. Let's take a look at Green's theorem. Green's theorem says let R be a simply connected region with a piecewise smooth boundary C oriented counterclockwise. That is, C is traversed once so that region R always lies to the left. If M and N have continuous first partial derivatives in an open region containing R, then our integral of m dx plus n dy we can rewrite in terms of the r, our x's and y's and so forth. Partial of n respect to x minus partial of m respect to y. So let's take a look at a problem. Okay, so we got this integral y minus x dx plus 8x minus y dy. For the path C, boundary of the region lying between the graphs is y is equal to x and y is equal to x squared minus 8x. Well, if I were to graph these, what I'm going to see is here is y is equal to x, goes up like that, and y is equal to x squared minus 8x. This will, trying to think if it's above or below that. Let's actually graph it on the calculator and see. Be a much easier way to do it. Okay, so let me bring up the calculator. I think it'll be below. I think there's any way it can be above. Let me press y equals, press clear. I'll put x on y1, and on y2 I'm going to put my x squared minus 8x. So x squared minus 8x, and then graph. Okay, that's what I thought. It is below. So we'll come back to that. We want to switch this over, and this will be our x equals, and this will be our x equals. And in order to find out what the x values are, I have to find the intersection of these graphs. So to find our points of intersection, our POIs, we're going to set the x squared minus 8x equal to x. Why do I do that? Because they're both y equals x, so I can equate them. And now I'll solve this. So I'll take the x over to the left side, and that gives us x squared minus 9x equal to 0. Factor out an x, GCF, and that leaves us x minus 9. Set each one of those equal to 0, and we get x equals 0 and x equals 9. So this goes from 0 to 9. Now our y's. We're looking at y is equal to x to y is equal to x squared minus 8x. If we come over here and look, the one that's below is the x squared minus 8x. So I'm going to put that here. Y is equal to x squared minus 8x. And the one that's above is right here. So I'll put that up here. Y is equal to x. Okay, now to our formula. That's the R region we just found. Partial of n respect to x. Well, this is m here. And this is n. So partial of n respect to x, taking the derivative of 8x minus y with respect to x, that gives us 8. Minus partial of m with respect to y. So I come over here, y minus x, the derivative, partial derivative of that with respect to y is 1. dy dx. And so that's the setup on that. Well, 8 minus 1 is 7. So that can go ahead and go out in front. Then we have nothing left here like an invisible 1. The integral of 1 is y, 1y or y. And that's going to go from y is equal to x squared minus 8x to y is equal to x. Well, now I'm going to plug those in for y. So plug the x in for the y, minus, and then we'll plug in the x squared minus 8x for the y. And I had to put parentheses here because that minus has to flip the sign of everything that follows it. dx. Do a little bit of simplifying before we find the next integral. Negative x squared. Negative gives me a positive 8x, plus the x gives me 9x. dx. Okay. 7 stays out in front. Add 1 to our power, divide by our new power, so we got negative 1/3 x to the third plus 9/2 x squared from x equals 0 to x equals 9. And now plug in the 9 for the x, so I got negative 1/3 times 9 to the third plus 9/2 times 9 squared minus, I put parentheses here because that affects the sign of everything that follows it. I put 0 in for the x. So I got negative 1/3, 0 to the third, plus 9/2 times 0 squared. Well, these zeros all over here cause this last part to drop away. And I'm going to type this in my calculator because I'm lazy. So do second mode. 7, beginning parentheses, negative 1/3 times 9 to the third plus 9/2 times 9 squared, so times 81. And then math, inner. And we get 1701 divided by 2. And that's our answer. Let me go ahead and save this. Green's Theorem, page 01.pdf. Okay, let's look at our next problem. Same instructions, tells us to use Green's theorem. Okay, so we got y minus x dx and plus 2x minus y dy. For the path C defined as x is equal to 5 cosine theta, y is equal to 3 sine theta. Well, if I divide both sides by 5 here, I'm going to get x over 5 is equal to cosine theta. If I divide both sides by 3 here, I get y over 3 is equal to sine theta. If I go ahead and square both sides, I get x squared over 25 is equal to cosine squared. And here I get y squared over 9 is equal to sine squared. Now we can add the left sides of each equation together. So I got x squared over 25 plus y squared over 9. And we can add the right sides together. So we've got cosine squared plus sine squared, which cosine squared plus sine squared is equal to 1. Well, this is an ellipse. Since it says 25 here, the square root of 25 is 5, so it goes out 5 this way. 1, 2, 3, 4, 5. Goes out 5 this way. Like that. Then 3 this way. And 3 that way. So our graph It's going to look like that. And okay, had to look at my notes on this because I didn't remember the formula. We'll get to this in a minute, but I didn't remember this formula, and I had to look to see what in the world the formula meant. Okay, let's ignore the region of integration here to begin with, and let's take a look at the m and n for our formula. This one has a note that goes along with it. Partial of n respect to x. Partial of n respect to x would be 2 minus partial of m respect to y. Partial of m respect to y would be 1. Now, whenever this right here gives you 1, then you can just, if possible, you can just use the formula for the area of whatever graph you're looking at to find out what this line integral is equal to. Well, again, I had to look this up. The area of an ellipse is pi AB. I'm not sure if we ever do cover that in trig. Now A and B, they come from these right here. And I don't remember which one's A and which one's B, to be honest with you. But you take the square root of them. So our answer is going to be pi times 5 times 3. So it's going to be 15 pi as our answer. So very simple on those, where you get 1 for this inner part. Then you don't have to worry about the region of integration. You just find your area with our basic geometry formulas. So I'm going to go ahead and save that. Now, if you can't find your area easily, then that may not be the best way to go. Okay. Let's take a look at this one. We got this, and y minus x dx plus 2x minus y dy. This is m, and this is n. Let's first just not worry about the region of integration yet. Let's check the partials. Go back up to our formula. Partial of n in respect to x. So partial of n respect to x is 2 minus partial of m respect to y. Partial of m respect to y is 1. And you notice we get something again here. 2 minus 1 is 1. So we can just look at the area of these. So let's look at the boundary and see what in the world we're talking about. C is the boundary of the region lying inside the rectangle, bounded by -2, x equals -2, x equals 2. So 1, 2, 1, 2, and y is equal to -4 and 4. 2, 3, 4. 1, 2, 3, 4. I'm gonna murder that dog. Yep. Actually, it's a bark, but it's my dog. Just can't complain too much. And outside the square, bounded by -1 to 1 on x and the y. That should be a square, but you get the idea. There we go. And what it's asking us for here is this right here. When we're talking about the area. So if I look at the area of my outer rectangle, it's going from -2. This is area of the rectangle minus the area of the square. Well, the rectangle, this is up 4 and then down 4 here, so it's 8 times, and then 2 over here and 2 over here, so that gives us 4 total, minus the square is 1 here, so that's 2 on that side and 2 on this side, so 2 times 2, which gives us 32 minus 4, which gives us 28. And that's our answer. So we'll go ahead and save that. And let's look at our next problem. Okay, so we got 3xy dx, so 3xy dx plus x plus y dy, and it's a pretty good bet this is not going to give us 1, and even if it did, finding the area of this may not be that simple. So boundary of the region line between the graphs of y is equal to 0 and y is equal to 4 minus x squared. Well, 4 minus x squared, that's up 4. Like that. And the y is equal to 0 will be the line going across there. So what we're working with, what we're talking about here, is the boundary of the region. So it's going around this right here. So that's our boundary. Okay. Well, you can kind of see it goes from -2 to 2, but if I didn't see that, to find our points of intersection, we would, since y is equal to 0 and y is equal to this, we just equate these two. So we got 4 minus x squared is equal to 0. Take the negative x squared to the right side, becomes a positive x squared. Drop our squared, put a plus or minus square root around the other side, and we get x is equal to plus or minus 2. So this outer one is going to go from x equals -2 to x is equal to positive 2. And then we're going to go from y is equal to 0, it's the one that's below, to y is equal to 4 minus x squared. Now this is our m, and this is our n, so let's go up and look at our formula now. Partial of n in respect to x. Partial of n in respect to x is 1, minus partial of m with respect to y. Partial of m with respect to y would be 3x. dy dx. So let's go ahead and find that integral. We're integrating in respect to y, so the 1 becomes 1y or y minus, and then 3x becomes 3xy. From y is equal to 0 to y is equal to 4 minus x squared dx. Now we're going to plug the 4 minus x squared in for the y. So we got 4 minus x squared minus 3x times 4 minus x squared minus, and then we'll put parentheses because we have flip sign of everything and follows it, and we'll put 0 in for y. So we get 0 minus 3x times 0 dx. Okay, well, this gives us x is equal to -2 to x is equal to 2. And we got 4 minus x squared. Negative 3x times 4 is negative 12x. Negative 3x times negative x squared is positive 3x to the third dx. Now I could rearrange those into the right form, but probably wouldn't benefit me a whole lot. Standard form doesn't add a whole lot. So we'll go ahead and take the integral with respect to x. So the 4 becomes 4x minus 1/3 x to the third minus 12 over 2 x squared plus 3/4 x to the fourth. From x is equal to -2 to x is equal to positive 2. Now let me double check that. 1/3 x to the third minus 12 halves x squared plus 3. Okay. We're ready to plug in our numbers, and we'll do a little bit of simplifying where I'm doing it. So I'll plug in 2 first. So I got 4 times 2 minus 1/3 times 2 to the third minus 12 divided by 2 is 6 times 2 squared plus 3/4 times 2 to the fourth minus, then we're going to have parentheses, we'll flip the sign of everything that follows it. We've got 4 times -2 minus 1/3 -2 to the third minus 6 times -2 squared plus 3/4 times -2 to the fourth power. Which gives us 8. 2 to the third is 8 times 1/3 is 8/3, so minus 8/3. 2 squared is 4 times -6 is -24. 2 to the fourth is 16 divided by 4 is 4 times 3 is 12 minus 4 times -2 is -8. -2 to the third is -8 times the -1/3 gives you a positive 8/3. -2 squared is 4 times -6 is -24. -2 to the fourth is 16 divided by 4 is 4 times 3 is 12, which gives us 8 minus 8/3 minus 24 plus 12. Minus flips the sign of everything, so it becomes a plus 8 minus 8/3 plus 24 minus 12. Now I didn't go ahead and combine anything together because I saw some of these were going to cancel. 24s are gone and 12s are gone. So we got 8 plus 8 is 16 minus 16/3. 16 times 3 is 48 minus 16 32/3. If I didn't make a basic math error somewhere. That's our answer. Okay, let's look at our next problem. So, number 5. Use Green's theorem again. This whole section is focused around that. And we got y squared dx plus 3xy dy. And C is the boundary of the region. Now, it's not the actual area. Now, if our partials gives us 1, then we can look at the area. But otherwise, we're just looking at the boundary. Line between the graphs of y is equal to 0, y is equal to square root of x, and x equals 16. Well, y is equal to 0. It's right there. Y is equal to square root of x. That's going like that. And then over here, at 16, we got the boundaries too. So we're looking at this right here for our boundary. So we need to know what our x values are. Well, it's kind of obvious. It goes from 0 to 16, but if I didn't see that, then I'd find the intersection of y is equal to 0 and y is equal to square root of x. So you set them equal to each other. 0 is equal to square root of x. Square both sides, and you get x is equal to 0. So that one's kind of, and this one's given to you direct. They say x equals 16. So this is going to go from x is equal to 0 to x is equal to 16. A lot of books don't put the x equals and so forth, and I find it just helps you keep things straight. Now this line right here is y is equal to 0, so that's our lower one. And our one that's above is the y is equal to square root of x. Okay, now this is m and this is n, so let's go back up to our formula. We need a partial of n respect to x. Partial of n respect to x would give us 3y minus, and partial of m respect to y. Partial of m respect to y would give us 2y dy dx. And that's our setup. So let's go ahead and find the integral now. So we got x is equal to 0 to x is equal to 16. And y is equal to 0 to y is equal to square root of x. 3y minus 2y is just y dy dx. Well, the integral of y is 1/2 y squared from y is equal to 0 to y is equal to square root of x. Now the 1/2 I can put clear out in front because it's just a number. And now we're ready to plug in those values. So we'll plug in the square root of x for y. So we're going to have the square root of x to the second power minus, and we'll plug 0 in for y. So we've got 0 squared. Well, the square root in the second power cancels, so that leaves us x, and of course 0 goes away, so that's x dx. So then this becomes, the integral of x is 1/2 x squared from x equals 0 to x equals 16. The 1/2 again we can put out in front. So we've got 1/2 times 1/2, and we'll plug in our numbers now. So I'll put 16 in for x. So I got 16 squared minus, and put 0 in for x. So 0 squared. And that gives us 1/4 times something. I don't know this. 16 squared. 256. And 256 divided by 4 I think is 64, but let's check. 64. So that's our answer. Let me go ahead and save that. And let's look at our next problem. Okay, our integral is x squared minus y squared dx plus 10xy dy. Pretty good bet that our partial is not going to give us 1. So if it did, then we'd be finding the area of this circle, which would be pretty easy. Okay, so our path is x squared plus y squared equals 9. So we got radius of 3. And the circle going around like that. Okay. Well, if you look at this, it's pretty obvious it goes from x equals -3 to x equals 3 if you know anything about circles. So that part's pretty clear. If I got x squared plus y squared equals 9, if I solve this for y, so I'll take the x squared over, we'll get 9 minus x squared, and y is equal to plus or minus square root of 9 minus x squared. So we got y is equal to negative square root of 9 minus x squared, and y is equal to positive square root of 9 minus x squared. Now this negative version right here, that would be this part that's underneath. That's this right here. The positive version right here, that's the part that's above. So in doing our setup, this is going to go from y is equal to negative square root of 9 minus x squared to y is equal to positive square root of 9 minus x squared. And this is going to be m, and this will be our n. So let's go look at our formula. Partial of n respect to x. Partial of n respect to x would give us 10y minus partial of m respect to y. Partial of m respect to y would give us negative 2y. dy dx. So we get x is equal to negative 3, x is equal to positive 3, and then our y is equal to negative square root of 9 minus x squared to y is equal to square root of 9 minus x squared. Now negative negative gives us positive, so that becomes 12y dy dx. I'm going to take 12 and put it out in front. And we got x is equal to -3 to x is equal to 3. And we're left with a y in there, and the integral of that gives us 1/2 y squared from y is equal to negative square root of 9 minus x squared to y is equal to square root of 9 minus x squared. The 1/2 I can put clear out in front, so we got 12 times 1/2. And then x is equal to -3 to x is equal to +3. And we'll plug these in. So I'm going to have the square root of 9 minus x squared minus, and then the negative square root of 9 minus x squared. Now, when you square something, it's always positive. So this becomes a positive. And if this is positive, then basically these are both the same, which gives you 0. So when I go through and do the integral of this, just gives us 0. Now, I could have switched this to polar form, but actually if you have a y here and then these are square roots, it's just as easy to leave in this form because those square roots are always going to drop away. So let me go ahead and save that. And then let's look at our last problem. I think that was this is our last problem. Yeah, it is. Okay, so use Green's theorem to calculate the work done by the force F on a particle that is moving counterclockwise around the closed path C. So we got 5xy plus x plus yj. And we got x squared plus y squared is equal to 16, which means radius of 4. 1, 2, 3, 4. So going around like that. Imagine that's a circle, and that's the path we're talking about. Now I put a hint here. It says change to polar form. Let's first take a look at this. This would be m, and this is n. See what that gives us. So come back up to our formula. Partial of n respect to x. So partial of n respect to x is 1 minus, and then partial of n respect to y. Partial of n respect to y would be 5x. Well, this one right here would go from theta is equal to 0, theta is equal to 2 pi, and this will go from r is equal to 0 to r is equal to 4. So here's r is equal to 0, the point here, and then r is equal to 4 goes out to here. Theta is equal to 0 is the starting place, and you go all the way around the circle, and that's theta is equal to 2 pi. Now remember that x is equal to r cosine theta. And not that you need it for this problem, but r is equal to, or y is equal to r sine theta. So this becomes 1 minus 5r cosine theta. And remember, we have to put an extra r on here whenever we switch it to polar. Okay, so let's do a little bit of simplifying. Multiply the r through. R times 1 is r minus 5r squared cosine theta. Dr d theta. So we get theta is equal to 0 to theta is equal to 2 pi. And we'll take the integral with respect to r. So that gives us 1/2 r squared minus 5/3 r to the third cosine theta. from r is equal to 0 to r is equal to 4, d theta. And theta is equal to 0 to theta is equal to 2 pi, and we'll plug in what we just, r is equal to 4, so we'll put that in for r. So we've got 1/4 times 4 squared minus 5/3 times 4 to the third cosine theta, minus, and then we'll put 0 in for r. So we got 1/2 times 0 squared minus 5/3 times 0 to the third cosine theta, d theta. Well, these zeros over here can't cause the second part to all drop away, so I don't have to worry about that. 4 squared is 16, divided by 2 is 8, minus 4 to the third is 64 times 5. Let me plug that in my calculator here. 4 times 5. 320 over 3 cosine theta, d theta. Okay, now let's integrate with respect to theta. So this becomes 8 theta minus, the integral of cosine is sine, so this becomes 320 over 3 sine theta, from theta is equal to 0 to theta is equal to 2 pi. Well, if we'll plug these in now, I'll have 8 times 2 pi minus 320 over 3 sine of 2 pi, minus, then I'll put 0 in for theta. So we've got 8 times 0 minus 320 over 3 sine of 0. Well, 8 times 0 is 0, that drops away. Sine of 0 is 0, so that drops away. Sine of 2 pi is 0, so that part drops away. 8 times 2 gives us 16 pi for our answer. So let me go ahead and save that. I believe that was our last problem. Let me see. Yeah, it was. So you can use it to calculate work. So Green's theorem, F10.